Hmm. Okay. Hello everyone. Today is my day 12 of my C++ DSA journey. In today's stream, we will be revisiting some problems, and after that, we will try some new problems. And if I will explain the my thought process during this process, and if I get stuck at any point, I will try to get hint, and if even after hint, we will be unable to solve the problem. If we were be unable to solve the problem, we then I will see the code and then try to understand it then, and we will work the problem together. So yeah, so let's start today's stream. So before starting today's stream, here you can see my LeetCode profile ranking has improved. So like from it, I think it was yesterday around 49 lakhs. I think it's increased because of I did these two problems. The first one was the monotonic array, which was an easy level problem. But after that, I solved this problem, which was product of array expect itself. So this was a medium level problem. I think lead code profile rankings have arrangement like this according to the number of problems or the level of problems that is solved, and not the count of problems. So yeah, this was this. So okay. Now what we will do first, we will first revisit the problem that we did yesterday. That was monotonic array. Okay. And what we did in this, we used two approaches. First, we used the approach that is not showing here. After that, we used this approach. This was the most optimized approach for this problem, in which we only used the return statement and return the answer. Okay. So first, I will go with the easy approach that I used earlier and understood it with the help of Copilot. I'm seeing here because I'm also watching if anyone has come on the stream or what, if anyone has joined the stream or, you know, let me reduce the quality. Okay, now I think it's fixed. Okay, everything is set. So what we will do, first I will remove this all, and first I will explain you guys the problem because what happened yesterday. Yesterday I did this problem, and after that I jumped onto this new problem. But in between this, the light was the electricity was getting cut so many times, and because of that, the stream got disturbances. It created disturbance in between the streams, and I have to I then have to do the streams in two parts. After that, I did it. But what happened in the last problem? I was unable to understand it fully and explain to all of you that problem in a good way. And I also have understood it. That is hard code for me also. So today we will understand this problem in a very good way and in a detailed way. Okay. And I will also be explaining this monotonic array problem first. So let's jump on to this. So the first thing that we have to write is okay, first I will explain the problem. So what is monotonic array? See, monotonic array is an array in which the values are in strictly increasing order or in strictly decreasing order. You can see here that 1, 2, 2, and 3, it is in strictly decreasing order. Like this is not like an order like if 2 is after 3 or 3 is after 2, then it will not be considered a valid monotonic array. Okay. And here you can see it is in decreasing order. And yeah, you can use the duplicate values in between. Just you need to check if the values are arranged in increasing order or in decreasing order. We need any one of them. If any one of them is true, then we will return true in the last. Okay. And if both are false, then we will return false. See here, it is not strictly increasing in manner or not strictly in decreasing manner. The You can see the sequence of numbers is not right. Like in between, this is the biggest value, and from here it is it is increasing, but after that it is again decreasing. So this is not a type of monotonic array. So what we will do first for this, so we will create two variables. We will take two boolean values. First we will name first value will be into decreasing, and in the start we will mark it as true in the starting, and we will create another boolean variable and name it as increasing. Okay, and we will also mark it as true in the first. After that, what we will do, we will run a for loop. Inside this, we will go from the first index to the last index. Okay, and I plus plus. After that, what we will do inside this, we will check for two conditions. Like if array is in increasing order, then we will mark the bool decreasing as false, because it will not be in decreasing order, and till the end, if this is true, like if it is increasing order till the end, then it will return true in the answer. And if it and in the second if condition, let me first write, sorry. And in the second if condition, what we will do the opposite of it. Okay. So let me write the code. If what I plus, okay. If num psi, okay. Num psi is what to num psi is more than, sorry, num psi is less than num psi plus 1. Okay. Then what we have to do, we have to make decreasing, we have to mark decreasing as false. Okay. Is my stream going on? Okay, stream is going on. And the second condition will be opposite of it, like if I copy it from here and we will paste it here. And what I will do, I will just change the condition like this. If nums I is more than nums I plus 1, means if the previous value is more than the next value, okay, then we will do, what we will mark increasing as false, okay, because then it will be in decreasing manner. And after that, we will check if increasing is equals to true or decreasing is equals to true, then if any of them is true, what we have to do, we have to return true in the end. And if both of them will be false, then I think well, it's gone. Okay, then let me first run the code. After that, I think there should be one more condition. It gave an error. I don't know why. Let me first fix it. Okay, not to match the solution, class solution. Okay, here the function has closed. Okay, so we need this extra. Only this is here. Okay, here the semicolon is missing. Let me check the code first. Okay, and yeah, there is also a thing that we can use a and the condition if num dot size is is less than 2. Okay, if num dot size is less than 2, what they will do? They will return true in this case because when there will be only one value in the array, it will be by default be true because it can't be neither increasing or decreasing. Okay, means it can be in decreasing order and it can be also in decreasing order. Let's check. Okay, the code is I mistakenly write the wrong code here. Then the condition should be if num dot size is less than 2. Okay, okay. After the function, we have to return false if both of them will be false. Okay, it's passing two test cases. That's great. The expected was false, but it is returning true. I think it's because let me see. It's not giving false in the expected statement. Okay, 132. This will become false. This will become false if what if we write here and what else return false compile error. If I remove this from here, so what the mistake is, I think that we did the mistake that I have done yesterday. In the true case, it's static giving true, but in the false case, it's again giving true. That is why I think, okay, I should start from the first index, right? If I start I from the first index, maybe, okay, it's again looking for the thing, but it's again giving true. I move the num dot size. Uh, 0, 1. I think I should ask it from chat copilot because just I will take the hint, not the code. if there any logic problem in my current code, just tell me that, give me a hint to me, not the code. Okay, okay. There was a catch, man. I think instead of for loops, we can use the, no, we have to use for loops in this because it's not for indexing. We are checking the values also. Yeah, there's a small. Okay, so I think there should be minus 1 because it is for I plus 1. Mhm. Okay, it's again running. Okay, loop. I have corrected the loop range because it goes from the first index, sorry, second index to the till then last element. But we are checking comparing I with I plus 1, so it gets out of the array. And that's why the last value gets left unchecked and we get a output result. Okay, there's a subtle logic issue. What is the okay, I think there is subtle logic issue. I'm checking inside the loop if yeah, I think that it should be outside the loop, man. Okay. Again, saying expected is true, but for expected is false, but it's returning true. What if we write else this here and after that we write the case in which return false. Okay, all the test cases are getting false. This will not be the test case. Sorry, it will not be the right code of for it. Nice. Okay, it's saying for checking monocity. Am I checking every consecutive pair. Is it mandatory or not? If yes, then loop starting index where it should be. Loop starting index. Okay, loops. I think if it's saying that we should start it from 0 and go to the last index value. Okay, it's working. So see, so loop will start from 0 and will go till the last index, right? Okay. Num dot size -1 means till the second last element. I will go to that, right, and I plus 1 will go to the till the last index. Exactly. Okay. Mm-hmm. Let me do one thing. Let me fix the lighting. I think the lighting is creating an issue. I think this lighting should okay now. The lighting is fixed now. Ho, 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 ho. Okay, and the current viewer here. But no problem. We will. Okay. So how this is working? See, in the starting, I marked the increasing and decreasing the astro using boolean values, using bool type. After that, I ran a for loop inside this. We go, we 1 minute. Okay. When we use this type of loop, like starting from 0 and using this condition like I is less than num dot size -1 means it will go from the very first index till the second last index, not the last index. Because inside this loop we are checking for I plus 1. Okay. And in the end it will reach I plus 1 eventually. So inside this what we are doing, we are first checking if nums I index is less than nums I plus 1 in the entire loop, okay, in the entire iteration. If this is true, if this is true, okay, if nums I means the previous value is less than the value next to them till the end of the array, then it will return sorry, it will mark to decreasing as false because the values are in increasing manner if this is true. And else, if nums I is more than I plus 1, okay, then what will happen? If the previous value, sorry, if the previous value is more than the next value till the end of the array, it will mark increasing as false because it is in decreasing manner. Okay, and in the end, after the loop ends, we check if increasing is true or decreasing is true. If any one of them will true, we will return true, and else if both will be false, then we will return false in the last. Okay. Why we use false? Because if it is not in decreasing or in increasing manner, then it will be a false because it is not. It is not then be a. It will not be a monotonic array then because in monotonic array we need uh, the numbers to be arranged in a strictly. Sorry, the values should be strictly arranged in a ascending or descending order. Okay, it doesn't matter if the values are duplicate or. or not. Okay. If the values are duplicate, just they have need to be placed at the right place. So okay, we only have to check that if they are in strictly increasing or strictly decreasing order. Okay, I think you got my point. So this was the code for it. And the time complexity of this code was big of n. Okay, this was equals to big of n because we only used single for loop here. It does beat 100% in time in memory, but see, there is another code. How it beats 100%, man. Yesterday it only beat 1 minute. Okay, okay. Brother, yesterday this code beats this code not beaten 100% in runtime or memory. When I revisited this problem today, how it is showing it beat 100%. Like yesterday, I solved it with another approach using built-in function like is sorted. Then it gave like it beats 100% in that case. I am talking about the LeetCode. This was the result of yesterday. Let's see what gives. Okay. Okay, this is a misleading metric. Relative comparison. Okay, it compares my solution. Okay, runtime memory status with the solution that I have submitted recently against the solution that I have submitted recently. And if at that time optimize the fast submission have came, okay, then I will have been shown low percentile. And if at that time, if submissions were heavy or inefficient, then my code was okay. Then it will show that it beats 100%. Okay, server order. Okay, sometimes backend servers. Uh, Sometimes there is load on backend servers and memory allocation can vary. That's why okay, that's why same code on different runs cycles. Okay, okay, so different timings and memory. Okay, okay. Beat 100% means that beat 100% not means that my code is objectively fastest. Just it shows that in that moment, data set my code is the most efficient in that time. Okay. So okay, leave that. Now what we will do? Okay, let's close this. We were here. Now what I will do. I will try to solve it with. I will show you the built-in function by using which we can short. We can what we can do. We can shorten the code and it will do the same thing just in short lines of code. Okay, like in less lines of code, and the code will look very smaller then. For this, we will first include in the header that what we will include algorithm. Okay, and set this. I will remove all this from here to here. Inside this, I will directly return what I will directly return. First, I will write a std. Std is, I think, is equals to standard, and I will again write steady. Okay. Inside this, I will use a function name is sorted. Okay, is sorted. Nums dot begin, comma nums dot end, or is sorted. Nums dot r begin, comma nums dot r end. Yeah, this will check it for ascending if it's in ascending order, and this will check if it's sorted in descending order. Okay. Yeah, okay. The syntax of this will be like this: is sorted, and here it will be sorted. Okay, because there should be gap between words, so we used underscores to show gap between words. Okay, see if the test cases are accepted again, and see if I show the submission first of that we used of the solution that we used before. It beats 100% time, and this if I submit this code, you can see now. Okay, it beats 28% in runtime because I have already used. Okay, so yeah, it was right. The copilot was right. It was a misleading thing. But see, it beats 92% in memory now. Okay, means it takes less space because we are. I think because we are using less lines of code and doing the things in this way. But the time complexity of this will be less in this case because we are using built-in functions. And the time complexity of this was, I saw it yesterday, it was showing that the time complexity of this was equals to big of 1, means it is the flat, you can say horizontal complexity. I am currently reading time complexity in the C++ lectures, but yeah, I haven't completed it yet, but it says the data complexity how big of 1 look like this flat line in the graph. Let me show you. I will use this analysis, the analysis progress. I will show you how this looks like. See, my current complexity is big of 1, and see, it is highlighted here. It is like a horizontal line in the graph. Okay. Means the more it is far from the y-axis, the better the code is optimized, and the time complexity is lesser. The more the graph is like near to the y-axis, the time complexity of it is bad then. Okay, I have learned I have learned time complexity at uh, till this point only, and the lecture is currently going on. I have not finished it yet. I have finished, I think, one third part of it yet, and yet the whole lecture is left to be finished. So yeah, this was this. We now we have till now solved revisited two problems. Sorry, one problem and did it with two approaches. That was monotonic array. And first approach we used for loops, and the time complexity of that was big of n. And after that we used a built-in function that checks if it's sorted in ascending order or descending order, and if I and of and the time complexity of that was equals to big of 1, and that is the best of time complexity you can achieve. Okay, if it is big of n, then it is the best time complexity. And big of n is also a good you can say a best type of time complexity after big of 1. Okay, after that as number increases, the time complexity gets worse. So the better the time complexity, the better it will perform in worst case scenarios where the input data is size is very large, like you know, where like if array like if there are larger inputs, like there are 1 lakh inputs or 1 million inputs, or you can say 1 billion inputs, then but the ranking increased so fast after solving these two problems yesterday. It was the 49 lakh, man, and suddenly it jumped on to 45 lakh. Okay, 46 lakh we can assume because it's near to 46 lakh. Now what I will do, I will jump onto this problem that I also understood half. It was half baked. Then okay, the solution was this, but we I can say that I have half understood it and wrote the code by the help of Copilot. So yeah, I will not flex that I have understood it or not. I have not understood it, and I am not accepting it. But I have done. I did the dry run of it in my mind before the stream in the morning time. After solving any problem or likely visiting, I will take a hydration break and name it as a hydration break. Okay, like like if I solve a problem, like what if I do it with approach and submit it. After that I will have water. Okay, I will hydrate myself because the weather is hot and I sometimes forget to have water. So what should I do first? I should first, I think, open the code that in which we understood that. After that, I think we will be able to write this code. The code for this. The code is not that big, but the thing that is the thing that is working in is the type of thing that we need to understand, and I will have to explain this to all of you also. Okay, let's close this. Now what? See, int first we initialize the variable with the number of elements in the array. After that, we initialize result array and initialize with 1. Inside this, there are number of elements same as number of elements in the nums array. Okay, we just created a new array and initialize all the values of them with 1. Okay, in the prefix pass, I think what prefix is doing in prefix. Brother, give me the dry run of this also in detail, in detailed way, and give me the code with this type for proper comment also. Today it was planned that okay, leave it first. Let me see a code. The weather is hot, man. Okay, leave it. Class solution public. Okay. Prefix is 1, result is 1 1 1 1. Okay. I 0 in the I index. The result will be prefix is 1 into 1. 1 into 2 is 2. 2 into 3 will be 6. 6 into 4 into 4. Okay. After prefix, the result will be after prefix result will be this. Result will be what 1 1 1 1 2 and 6. Oh man. Let me see what it said. Okay, this is the array. Let us take an example. Start prefix. After that, it runs for suffix loop. Start prefix like this. I at 0, result is 0, index is equals to 1. Okay. Prefix in prefix will be 1 into 1. Okay. In the I when I will be on second iteration means it will be on second first index, that is 2. Then in the result we are on it on the second first index, that has value 1 stored inside. And what we will do, we will calculate prefix like prefix is equals to 1 into 2. Okay, the value into the current value of array. Okay, so that these till we will go till the end. But wait, 1 into 1. Okay, 1 into 1. Then I will be on its 0th index. Then I will be on its first index, 1 into 2. So that when I will be on second index, that is 3. Then what it did 2 into 3, not this. So, mm, 1, 2, 3, and 4. 1 into 1 is 1. 1 into 2 is 2. Okay. But left side is this, man. When I will on this first iteration, it says that each index has product of left side only. But how, man? See, left index. If it's on first index, then it will be 1. When I will be on its second index, this then how it's calculating like this: 1, 2, 6, and 4. So 2 into 6 is 4, and 6 into 4. Okay, so this how then 1 will initialize it with 6 and multiply it by 4. How? 1, 1, 2, and 6. Okay, so prefix I think get set. Okay, I'm taking a 5 minutes break. I will be back in 5 minutes. Okay, I will be back in 5 minutes. I'm coming then. 5 minutes. Give me 5 minutes. Okay, I'm back. I'm back. I'm back. Let me see. Okay, mic is working. Hello, hello. Don't know where those guys get gone. Those who came to my stream yesterday. Okay, where we were understanding this problem. First, I think I should understand this code. We will understand it block by block. Okay. First, I will understand this block. So in prefix is initialized with one. Okay. It starts from I okay side that we used for loop. It goes to the last index from the very first index. A result index value is equals to prefix. Product of all elements before I. For the next index. Result index value is equals to prefix. So prefix all the result value is equals to prefix, I think. Product of all elements before index I. But then why it's written inside this one? Whether first you explain me the code like block by block and in a proper way because it's not getting in my head. Can you do it? It will have to do it, man. It will have to do it. Okay. N array side result output array created and said that every element is initially one. Okay. So this array will become the final answer. Okay. Block 2 is prefix pass, left side product. In prefix, okay, till the left, okay, till now left elements product, okay, it stores the product of the elements, left elements till now, okay, at every index, okay, at every index result I is equals to product of all elements before I, okay, at every index. Then prefix update gets updated by multiplying with them's nums I index, what? Nums I value. If prefix is set to 1, okay, in this case, and when prefix will be updated with nums I index value, then in the starting it will be 1 into 1, then 1 into 2 will be 2, then after that 3 into 1 should be 3, man, then why it's not being like that? Okay, 1 into 1, then it will happen when I think I will be on second iteration because it's excluding the current value, current index. So when I will be this on this index, then it will. But let me see. Okay, after this loop, inside result index values, left the product of left side values will be inside that. Current index gets excluded, but how this is working, man? Update prefix to includes nums index. Update prefix to okay prefix. Prefix is not an array. Prefix we are just updating prefix. So prefix after that we put this prefix in the result array. What we are doing, result array values. What is happening? Result values is equals to prefix product of all elements before index I, and prefix is set to 1. If I go there and try to understand it from here, int prefix is equals to 1. For I here loop in the result index values, what we are doing, we are pushing prefix, and prefix. Okay, I think I understood it. When I will be on second index, that is 2, then it will happen. First it will be 1 into 1. It will be 1 because prefix is initialized with 1. Okay. After that, when I will be on its second index, then it will do what it did before. See here, it did 1 with 2. Okay, and prefix was already initialized with 1. So in the first run, it did 1 into 1. After that, 1 into 2. After that, it happened 1 into 2. So I think it is working like that, excluding the current index value. But in the first, it will exclude the first value also. After that, it will run. So excluding the first value, and prefix is already set. And what it's pushed in the result index value, prefix is getting pushed. Prefix is getting initialized. Then prefix is into equals to num's current value. But how this is working? The prefix into equals to num index value. Okay, it's just 2 line of code, man. Why it's not getting in my head? Hmm, I think we understood this part of the code, but what's happening here? Let me see. Okay, after prefix, the result will be equals to 1, 1, 2, 2, 6. Each index has product of left side only. 2 into 3 and this third 6 into 4. After that, hmm, okay. When it pushes the result index value into prefix, okay. When it says result index value, current result index value with prefix, after that, what it does when I will be on its second iteration, okay, prefix result will be result next index value of result will be calculated like 1 into C. Yeah, 1 into 2 is 2. Okay. Uh, and yeah, in the second iteration, it is happening because before the second iteration, prefix already get multiplied by num psi, current value of num psi. So that's how it is working. And in the end, what we get in the result array, we get the value 1 into see 1 into 1 first before the first in the first iteration 1 into 1 because prefix is already initialized with them. In the second uh, prefix is 1 into 2 because I is on this index and it's on its second iteration, and prefix is now in the prefix 1 is stored and 1 into 2 is 2. After that, when I will be on its third iteration. Now prefix will become 2. Okay, because see here, prefix is getting updated after every element is reinitialized with prefix. Okay, reinitialized with the product of left side. Okay, after that 2 into 3 because this is 3, and what it's doing, result I index value is equals to prefix. Okay, prefix is 2 here, and I it's on its third iteration, so it will consider what it does. When I will be on this index, okay, I think we understood this a little. Just the dry run is getting little messy. Okay, prefix in 1, then okay, this is this. Then I will be on a second index, and prefix will set like this 1 into 2. But how the after values are 1, 2, 3, 4 because of this. Like I start from 0 and okay. And after prefix, the result is equals to 1126. 1264. Okay. In the result array, see, this is getting, we are getting this inside result array. We are getting the prefix value in the result array, right? Like see, prefix is 1 into 1. Is 1 into 2 will be 2, 2 into 3 will be 6. Okay, first it is 1 in the first iteration. Second iteration will be in 1 into 1. Third iteration will be 1 into 2, 2, and fourth iteration it will be 2 into 3 is equal to 6. And it will not go to the last iteration because in the last iteration I will be on its last index. That's why. Okay, this is how prefix is working, and it's storing the values in the result like this. The sum of products. Okay, the sum of values before. The sum of values excluding the current excluding the current index value of nums, like it is storing the leftmost values, excluding the current value of nums. Okay. And the result is storing this. Prefix okay. Prefix 1 has now become 1, 2, 6, and 24. And what happening in suffix? See, suffix is like it's starting. Okay, it's started from the second last index. Let me see. Because it is initialized with I is equals to number of elements minus 1. I think it goes to the second last index, and I is more than 0. Yeah, I is more than equals to 0. What does that mean? Let's state here in the suffix pass. Okay, suffix pass right set product. In the suffix, just the namings are changed and the for loop conditions are changed, and we initialize the suffix with also 1. We initialize suffix with 1. Okay, for result index values into equals to suffix. Okay, after that, in this, what we did, we set the result index value as prefix. Okay, excluding the current index value of nums. Okay, see, and it gave the values till the last element, till the last num psi. Okay, excluding the current num psi value and the values at right side of it. Okay, that's how it worked, and give the product of all the values before num's current num psi, means left side of the array. Okay, and in the suffix, what it does, in the suffix is also initialized with one, so it goes to the second last index. Why it goes to the second last till the second last index? Because we are checking for the right values. Then next understand multiply with product of all elements after index I. Okay, if index I is here, then multiply the values of all the product. Sorry, multi multiply with product of all elements after index I. Okay, this and this and this and this. So it will string and I minus minus. Here I am also getting decrease. So suffix, okay, till now right elements, it stores the product of right element, and at every index of I, it multiplies the result I index value with suffix right side product. Then suffix, then it updates suffix by multiplying with num side. Okay, prefix left side product on the suffix. Okay, so 1 into 24, 24, 1 into 12, 12, 2 into 8. Notice 3 excluded. When both will be included, 1 into 24 will be 24, 1 into 12 will be 12, 2 into 8, 2 into 16, 6 is no brother, this is, it will, let me see here, the suffix loop, what we got. Okay, 12, 8 and 6. 24, 12, 8 and 6. Okay, it starts suffix from 0 on, okay, it goes till the last index. Yeah, it does goes to the last index. When I will your I is on third index, means last index, the result is equals to, how it became 61 man. In the suffix, we are doing the opposite of it. Okay. Mm-hmm. 61 is equals to 6, 24 is equals to 8. Further, give me the proper dry run that you gave before. Okay, nums result prefix 1, prefix loop, variable 0, okay, result prefix. Result is 1 and 1. Result is equals to, after prefix loop, result is 1126. Each index had the top left side only. Current excluded. So 2 into 3 is 6. 1 into is 2. 1 into 1 is 1. And starting it's 1. Suffix right side loop. Right suffix loop right side product only. Start suffix is equals to 1. I is equals to 3. Result is equals to 6 into 1. Okay. Like it's suffix loop I is equals to and minus 6 into 1 equals to 6. Suffix will be equals to 1 into nums index. So I will have to understand this. After that we will have covered we will have covered most of the part. Yeah, this is the main part. I'm getting confused here because uh, there are two types of values like prefix and suffix, and the result vectors is getting updated, so it's a little bit confusing. Um, the result vector we stored this, and in the prefix, okay, 6 into 424, but 1 to 624. 1 to 6. Is there any role of it here? I think yeah, 6 to 1 and 1. Okay, so this is the result vector of in this prefix values are stored. The multiplication prefix values are stored. Okay. In the suffix, what we are doing, what we are multiplying suffix values in the result array. We are multiplying. Okay, result I is equals to result I into suffix. Okay, suffix starts from what? Suffix starts from 1, and the it starts from the second last index bit, right? Let me suffix start from the second last index or last index, like inside the loop. You said suffix. Okay, I n minus 1. N minus 1. I is equals to n minus 1. Then, okay. So because in the starting I was, we started I with 0. So yeah, n minus 1 means it will go to the last index. In this case, if it was 1, then it will go to the second last index. Okay, starts with last index, and what it does, 6 into 1 will be 6. 6 into 1. Okay, suffix is equals to 1 into nums I is equals to 1 into 4. Result will be 1, 1, 2, 6. The last value will be 6, right? Okay. The last value is 6, but how it given 6? Okay. The loop has started, but it's excluding the current index values. Okay, result is 0. Add the result 0 in there. Prefix is equals result is prefix is equal to 1. Prefix is equals to num 0 is equals to 1 into 1 square. Result will be 1 into 1 into 1. Okay, this is prefix loop. We are on suffix loop. Last index is fixed into 1, 1, 4, 12, and 24. How these values are, how it's giving these values. Result 3 is equals to, okay, when I will be on a third index, mean 6 into 1. More than equals to 0. Brother, explain the suffix loop like y more than equals 0 or like how the values we are multiplying the result vector values after basic product includes nums I value for next index moving left. We also initialize suffix with 1, okay? In the first division 1. After that, we multiply it with current value of nums I means when I 2. Okay, so 4 into 2 is giving here. Sorry, 6, 2, 1, 1, 1, 2, 6. Okay, so 2 into 4, right? 2 into 4. After that, 1 into 12. How? 1 into 4 is 4. Okay, 4 into 3. Yeah, 4 into 3. But how, man? How? It's a little bit irritating. Hmm, why I loop last index? Okay, because we have to start to loop from the last index. Because suffix is equals to right side product. When I is more than 0, I is more than equal to 0, means it covers every index and till the 0th index. If I more than 0, if 0 dot I is more than 0, then 0th index will get skipped. That's why I is there. How it works, start suffix multiplication identity means no right product at this index. Result I already has left product from prefix and we multiply it with a right product. Suffix then equals to I. Suffix, then we update suffix by including current element so that Okay, so that right product is ready for the next index. Yeah. So that's how it becomes left into right product and current index gets excluded automatically. The prefix, okay, I is equals to 3, 6. The suffix is 14, 6, 8, 12, 24. Okay, suffix starts from the last index and move to the left side, to the left side from the right side, and every step multiplies the result I index value with right product, okay, and current index gets excluded. But how? If we see, we are on suffix the first iteration, it will be on the last index of the result, and what it does multiply it with 1, so it will be 6. Okay. After that, the suffix is now how these values are coming 4, 12, 24, 24. Suffix is 43, 124 to 41. So you will see that result second index is 8. I think these are the address. Have you also given the addresses like why those big two values? 4 into 3, 1 into 2, 2, 2 into 4, 2 into 4, 1 is included. I am talking about this. Likewise, suffix likewise result in result it is doing 61, comma 24, comma 112, etc. And also the same in suffix. Okay, we are actually writing the actual multiplication steps. 6 into 1 is equals to 6. 2 into 4 is okay. 1 into 12 is 12. 1 into 24 is 24. And suffix 1 into 4 is 4. 4 into 3 is 12. 1 into 12 into 2 is 24. 24 into 1 is 24. Final result. Wow, wow. You can also give me the easy way, man. Why did this? Great, you're great, man. Great. Very great, man. Now give me the correct dry run. Man, good, good job by wasting my time. Very good. Oh, okay, okay, okay. The suffix loop. Result with okay. Result 3 into 1 6. Suffix will be equals to 1 into 4 because see here suffix is this and 1 into 4 is 4. And after that the suffix will now become 4 into 3. 4 into 3 is 12 and 3 into 2 will be 4 into 12 into 2 will be 24. Yeah, suffix will become 24 after that and then suffix will be 24 again. And we get in the result that result vector is this. So have anyone came to the stream? I think someone came. Yeah, someone came in the stream but left. Someone came 2 times in the stream but left between. Okay, hello. These things happen. I is equals to the suffix. What it is doing? It is doing that it is multiplying all the values from the very last index to the very first index in the result vector with what with suffix values. Okay, 6 into 1 is 6. After that, what? To that, yeah, and 2 into 4. 2 is the second index, second last index value of result vector, and 2 into 4 because suffix is not updated. 1 into 4 suffix is updated, and so 2 into 4 will be 8 and it will be stored in the second last index of result vector. After that I will decrease and will be on first index, means this index. And what will happen then? Then suffix have now increased, suffix have now been recalculated and it is now 4 into 3, that is 12. Now what it will do, it will in the result it will multiply 1 into 12 and 12 will stored in this, and suffix will be recalculated like 12 into 2, and like 12 into 2 will be 24. Suffix has now become 24 and result is looking like this till now. After that, when it reaches the zeroth index, like p, when it reaches the zeroth index, that's why we use the 0, so that num psi current in value of num psi reaches the zeroth index in the reverse manner, and result in the result vector first index value, it will be equals to 1 into 24, that is 24 is suffix value, so it will be 1 into 24, and suffix will now become 24 into 1, it's 24, and in the result we will get 24, 12, 8 and 6. So final output is this. I think you guys have understood the things, that's how the things is working. So can we write it by cell? I think we can write it by cell. So let me remove it from. Okay, we have removed it. First, we will create a vector. And this OBS is disconnected. I don't know why OBS was disconnected in between. Okay, vector interior. Result. So that's what we've done. First, before this, we will create integer n is equals to num dot size. that this we will pass n and initialize all the values with 1. Okay, after that we will write the loop for prefix and initialize prefix is equals to 1, and we will write a for loop that goes from the 0th index till the last index, and I plus plus set this we will calculate the sum of rightmost, product of rightmost values including the current index value. And how it will be done? It will be done that the result index is into, sorry, it's equals to, this is, it was the equals to what? Yeah, it was equals to prefix. I was right. So it was equals to prefix. After that, prefix will be multiplied, prefix into equals to current value of num_sci. Okay, so when I will be on its first index, and prefix is already set, and this will get excluded, and will in the result push, we will in the result set the values, give the product of value multiplied with prefix, and prefix is now is currently 1, and 1 into 1 will be 1, and when I will be on its second iteration, then prefix will be set to 1. Okay, and result will be again calculated, and again it will give 1 into 1 is equals to 1. See, I show you. See here, 1 into 1 is 1, and 1 into 2 is 2. Okay, 1 into 2 is 2. Prefix is now become prefix into equals to num_sci. Okay, after that, what has happened? After that, when I will be on its third index, means sorry, second index, that is third iteration of I, then result, in the result we will push the prefix is equals to what? The prefix is equals to 1 into 2 is 2, so 2 into 3. Okay, 2 into 3 means prefix is 2, nums 2. Prefix is 2 is equals to 2 into nums 2 will be 2 is equals to 6. So 1, 1, 2, and 6. Okay. So I was right, it will be 2. It will be equals to 2, and after that, the prefix has updated again, and in the prefix, it prefix has now become 6, and 6 into what? And then the prefix will be stored like 6. After that, prefix will be updated 24. So this was all the values of prefix. After prefix loop, we get this result, and now I will write the block of code for suffix. Okay, and we will initialize the suffix with 1, and inside this we will write a for loop which goes, which is equals to n minus 1, and I is more than or equals to 0 means it goes till the first index, like when I give this decrement operator. Okay, so it goes to the very first index excluding the current index, and inside this what we are doing, we are doing the result index uh, into equals to current value of suffix. Okay, after that, suffix is updated with the num I value, because we are calculating it for we are calculating the product of value of the right side, okay, excluding the left side current index value. And this was suffixing working. After that, we will return a result vector after that. We return result. The semicolon is missing here. It will not work. With time, with practice, it will. Okay, something is getting wrong here. Let me see. I is equals to n minus 1. I more than equals to 0. I minus minus. Result index is equals to suffix. Okay, suffix into equals to. Okay, there I forget to use this multiplication sign symbol. Okay, so the code is accepted now. What if I write my own test case? Set of array, okay. Let's. What if we take the numbers like 24, 36, 48, 54, 29. Let's see. Will it take the values, these values, like okay, values from minus 30 to 30 only. So what we'll do, 12, 14, 16, 18, and 20, 24, and 30. My voice is coming, right? I am audible. I am audible. So I will submit it first. And the time complexity of this will be equals to big of n because we have used single for loops here. What is this problem? If I see it, I have done this problem. I think let me see what is the problem. Okay, maximum product stub error, given integer error. Let us case this 2,3. Okay. So it's related to dynamic programming. Now what I will do, I think I have explained a little, but it's better than before, like yesterday. So yeah, this is calculating the product of value that is there to the right, excluding the current value of num psi, like prefix is getting multiplied by the values stored inside a vector result vector. Like prefix is also getting prepared as an index, and it's what prefix is doing. Prefix is excluding current value of num psi and is giving the product of values that are to the left side of the current value of num psi and excluding num psi and the values after it. After that, what suffix is doing? Suffix is doing opposite of it. Suffix is giving the values. Suffix is giving the product of values after num psi means excluding num psi and the values before it. Okay. So and in the end we get the result array with the prefix and suffix values combined together, and in the end we get the result vector and we get the product of all the values excluding the current values of num_sci. Okay. So for both the directions we use this, and this was all the code for it. Now we have used solved it. What I will do, we will revisit it tomorrow, so that with time it will get inside our head, and yeah, we will understand the pattern and get familiar with these things. Now the conditions are small, but the 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 code is easy, but the thinking that it requires um, takes brain power, and with repetitions, what will happen? With repetitions, we will get to understand the patterns, and yeah, we will with time we will recognize the patterns, like how the things are working. So that's why revisiting is necessary. Okay, now we have done this. Someone is watching the stream, but he is not saying something. Okay, now what we have done today till now, we have first revisited the problem monotonic array and did it with two approaches. First one was a better approach, I think. After that, we did it with most optimized approach. Then after that, we revisited this problem and tried to understand it with Copilot first, and after that, we understand the code block by block. After that, we tried to understand the dry run of it also in uh, in parts, in different parts. Okay. Now what I will do, now we will try to solve a new problem. Let me see that what was the name of that problem. I will keep it open here. The chat will be opened here. The name of that problem was here. We visit improvements. Okay, so it is suggesting that I should solve this problem. That's name is merge sorted array. Let's see what's given in this problem. Okay, let's jump onto this problem. Every time we open a new problem, the heart's beats a little faster. Okay, wide merge. Okay, there are two arrays given, and we have to merge both the arrays like this. Okay, two pointers and sorting will be used. And array, okay, arrays, yes, it's an array-based problem, and two pointers are being used in this, and sorting is being done. Let's first see the problem. You are given into integer arrays nums1 and nums2. First, let me finish these things also. It's been kept for there for a while. So we can say that it's a small brick. Till then, you guys try to understand the problem, what the problem is saying. Mm, okay. Just about to finish this one. After that, I will write a little code, and there is so much left to it, but we'll eat it after writing the code by self. And if it's not work, then we'll eat again. Mm, part by part. Okay, we created two variables. It is saying that can you come up with a solution that algorithm that runs in big of m into n time? Okay, means I think we can use two for loops. First for loop is will run for m and second will run for m. Okay, n m less than what? Okay, int I will be equals to 0. I less than m plus n I plus plus. Set this, we will write another for loop. J is equals to 0. J is less than n j plus plus. Okay, what that we can do set this, I think. And yeah, first let me explain the problem a little. The final sorted array should not be returned. And yeah, let me start from here. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. Okay, okay, it is in increasing order, and two integers m and n and representing the number of elements in nums1 and nums2. Okay, m and n means m is the number of elements in the first, and n is equals to number of elements in the second array. Okay, the final sorted array should not be returned by the function, but instead be stored inside the array of nums1. Okay, means we have to store the nums second values at the place where zeros are given in the nums1. Okay, and it is just place. It is behaving like a placeholder here. To accommodate this, nums1 has the length of m plus 10. See, nums1 has the length of m plus 10, where the first m elements denote. Okay, denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has length of n. Okay, in this example, see, m is 3 and n is 3, but did we created an extra space in the array and initialize it with 0, I think. After that, we store nums2 values in the index which are 0. So here's the code. I did it like this. For j, I think we have to check I if nums I if nums I what if nums I index value is equals to 0, then we have to initialize nums I index value is equals to j and j plus plus plus. Okay, it will it will not run like that, man. Num size equals to j. Okay, sorting is already done here. We have to use two pointers. It's saying array two pointers. So two pointers will be used here. First is j, second is okay. First is I, second is j. So if any by any chance num psi value is equals to 0, num psi is equals to j. And after that, what we will do, we will return num1. And yeah, nums1 index value, in any case, then nums1 index will be equals to what? It will be equals to nums nums2 j. Okay. I return nums1. It will not run, or maybe will it run? Redefinition of an. Let Let's take a hint. Let's take a. You can easily solve the problem if you simply think of two elements at a time rather than two arrays. We know that each of the individual arrays sorted. Where what we don't know is how they will intervene. Can we take a local decision and arrive at a to simply consider one element at each time from the two arrays and make a decision, proceed accordingly? You will arrive at the optimal solution. I think there will be a function used in this, like find or something. Okay, let's get a chat here. We will pin this because we will again revisit this problem. So there I am writing code. Should I name it I? And okay, I will name it what? I will name it A and will name it B. And here A and B, parent will be B. Let's see if it is the same error again. Undeclared identifier I. Okay, undeclared identifier of I int I is equals to nums1 dot size. But wait, then it will okay. Int I is equals to okay. I now understood what int I is equals to A plus B. J. J is equals to B. All LeetCode have came till this point. What do you think? Am I going in the right direction? Or what? 1 minute. Let me tell you before and pressing the enter button. I think in this, I think we have to use a find function, or if nums2 not it's not present in that, and this condition is also true, then I think we will have to push back the values of nums j into nums I. Okay, let's see if it's this the case. Okay, I'm going off track here. Choosing your current code, return type mismatch, wide merge, but at the end you're writing return numbers, so that's invalid because okay, we are wide. Okay, wrong. Your loop I from 0 to replace B and J from 0 to B and just replacing 0 in nums 1 with elements of. But the problem is about replace zeros. It's a problem isn't about replace zeros. It's about merging two sorted arrays into one sorted array. Unused parameters MNM. You could skip you n number of elements in nums 1 and n number of elements in nums 2. You are ignoring them and using dot size, which is not correct here because nums 1 has extra space at the end. Correct approach to pointers. Brother, don't give me the code. I asked the approach and hint. Think about the extra space in nums1. Nums1 in the last, okay, and there and it's not given. Okay, inside that we have to fit nums2 elements. Used to pointers from the used to pointers from the end. One pointer, okay. One pointer will be on nums1 last valid index. M minus one, and j pointer will be on nums2 last index. Okay. Then again a third pointer that that will be placed on m plus 1, m plus 1 minus m plus n minus 1. Okay, means it will be placed at the very last index of the nums1. Compare and fill backwards when I and j both are valid. If nums1 index is more than nums2 index, then nums1 constant is equals to nums1's constant is equals to nums1 index value or I minus 1. Else nums1 constant is equals to nums2 index value and yeah, can lead to problems. Nums1 excess zeros have already been given only for space. Directly replacing them is not a solution. We have to ensure that final array is sorted. If we only replace zeros, then order will be okay. Yeah, we have to return the resulted vector, merged vector, and in the decreasing, non-decreasing order. Right? Should I make in the code? It's saying use emerald instead of num size. Okay. I have to use actual valid arguments. Okay, instead I have to compare the both last elements of both arrays, and we'll have to fill nums1. We'll have to start filling the values from the last index value of nums1. Means okay, loop logic change will change. Instead, I have to compare it. Okay, I am. What if I did do this? Okay, okay, I have fully removed the loop for now. Just initialize a comma b with m plus n comma n. Okay, pointers, we have to set pointer size equals to m minus 1. I is equals to, okay, I is equals to m minus 1. Integer I is equals to m minus 1. J is equals to n minus 1, right? And k is equals to m plus n minus 1. So every one of them, first we'll go to the last index. Okay. So on the last index of m, last index of j, last index of m plus n, both means both both m and n array. Okay. Main loop while I is more than equals to 0 and then j is more than equals to 0. Okay. We have to use while loop instead of. Okay. Uh, the class is closed here, and the function is closed here. Now what I have to do? I have to write a while loop, which what was the condition? I is more than equals to 0 and j and j is more than equals to 0. Okay. J should also be, yeah, more than equals to 0. The value should not be in negative. I is more than equals to 0 and j is also more than equals to 0. And then what after that? After that, we have to compare nums I and nums j. If nums I k, which one is bigger? We have to put that into nums1 k, means constant. Okay, constant index value. And if num size what compare like to which, if num size bigger than nums j or num j, okay, nums I, sorry, nums j is bigger than nums I, then what we have to think, we have to write two if conditions, because we also have to decrease the index values also, and also k will also be decreased. So if this is true, then we have to push it into nums k index, and inside nums k index is equals to what, is equals to the big value of num size big, then it will push inside that. And k minus minus, okay, k minus minus, else if nums nums k is bigger than nums I, okay, nums1 nums1 and nums2 index, and the nums1 index, hey, it will be nums2 and nums1. If this is true, what we have to do, we have to push the value of nums j side that. After that, we have to again decrease the position of k. Okay, this is like this. So that leftover case, if nums2 elements are left that are, if they are more than equals to 0, we have to directly copy them into nums1 k. And let's see if the code till here is right or wrong. Okay, there's some mistakes that we have to fix right now. It's saying duplicate variable declarations. Int I is equals to m plus 1. Okay, wrong while condition. Okay, more than equals to 0 will be like this. This is the right condition because I and j zero index is valid. Wrong comparisons. I am doing nums1 j nums2 nums1 index and nums2 index compare nums2 j index nums1 psi nums2 j nums1 j k num okay nums1 yeah nums1 constant it will be nums1 and it's saying that wrong comparisons we always have to compare. So I think the else condition is not needed here. So if we remove it, in the else case, it will be like this. Okay, nums1 and position. Let me check if this is correct. No. Oh, okay, there are some small mistakes. Braces are okay. Okay, we have to write else also. Let's write else afterwards. After I. In the index decrement missing. When I use nums1 index, after that I should do I minus minus. Okay. Yeah, yeah. I I minus minus and J minus minus because the index values are decreasing together. Variable naming at the same time you can say not together. Okay, I'm writing nums J. Okay, nums2. Yeah, it will be nums2 here. It will be nums1. Okay, okay. Correct skeleton. Important. Okay, if else, so we can write this will be executed every time, yes, if any of them is true. And k will be okay here. K minus minus. It will decrease the k index value. Index k index number. Okay. If nums2 elements are left, while j is more than or equals to 0, nums k is okay. But why it will be left after that? But why some value will be left like that? Okay. I run the loop from live while I is more than equals to 0 and j is more than equals to 0. Means till both the pointers are valid, both arrays pointers are valid, then we compare and pushing and putting the bigger element in nums1 index. Why pushing the bigger values at the end? Because it is given that we have to return that in non-decreasing order. Okay, means it should be in increasing order. Okay. But nums1 elements. Okay. But if nums1 elements get finished before nums2, and after that if there are some values in nums2, if some values are still left and it's more than 0, then main loop gets stopped, and in that conditions nums2 elements haven't been copied yet. That's why we use this extra loop. While there is more than 0, nums1 constant is equals to, because see, because we fill these values, I think after that simple example here: 6 versus 3, 5 versus 4, 6 versus 3, we have 5 versus 2, 4 versus 1, and every nums1 big elements are put inside that, and now I have become less than 0, and inside nums2 1 2 3 is still left here, because the nums2 values are smaller, so we have to put it in the front of the array. In this case, what we will do, we will use this as test case also. So first let me write that thing. After this, the a while loop starts there and ends here. Okay, so we will again write a while loop. While j is more than equals to 0, while j is more than equals to 0, what we have to do, nums k index value that is left after doing this. Okay, so nums in this case nums2 current index value, from which it starts filling j values, will be 5, 4, 3. It will be 2. Okay, then 1. Then after that it will become 0. 0 means the first index, because 3 values are left in j in this case. So nums k will now become nums2 j if it's left in that, and what we'll do, we will decrease k every time when j is filled inside that compiler. While what is the member name, or okay, nums, we forgot to num2 j. Did what getting wrong here? Okay, it should be not. Okay, it will be. It will check the J index value. If not, if it's not become has not become zero yet. Okay. Unexpected member name or while loop. Okay, if condition one, else condition two is here. So that after if else while loop ends here. There's an extra while loop ends here and functions end here. Undeclared identifier nums. Okay, nums one constant. Runtime error overflowed. 1 minute. Expected output. Okay, okay, bus what? Just a small mistake is left. Okay, I forgot to decrease J here. A little mistake. See, okay. So the curly braces, the that was an extra curly brace here, there also. So now the code is running, and this is how the code is working. Let's see, ask if so. Can I say that I have wrote the code by myself or what? Because because I'm currently on live stream and doing doing a learn in public. Nobody, I think nobody came today on the stream. Just me and myself is watching the stream. But it's okay. Not today, maybe tomorrow. Someone will come. Will the test cases be also accepted? Okay. It beats 9% in memory. Okay. This is misleading. Copilot told it before. Intervalist reaction. Okay. I think the time complexity of this will be equals to what it was said in this, like big of n plus n, because you know that we use three pointers, but this pointer is using both, and yes, if it was only one pointer like n that was using while or while loops, then it will be n, but here it is n plus n because it is running n plus n times. Okay, I wrote the code by myself and did debugging of it step by step. Mistakes happen, but debugging is the real learning. Yeah. Okay. We will leave that. So now I think I should give the dry run also by myself. So the starting int I is equals to m. It starts from the last index of the first array, and it starts from the j starts from the first index. So sorry, last index of the nums2 array, and k is equals to k is the constant value of m plus 1 means this n plus n means it creates access space in nums1 also. Then we will use that inside this. While I is more than equals to 0 and j is also more than equals to 0 means I have not become I have not come I is not less than the 0th index and j is also not less than the 0th index. Okay, it will go till the last index of I and j. If nums1 index is more than nums2 index value, okay, because we have to arrange in this both of these in right order. See here, 2 is at the first and here 2 is at this position, but in the result it is in a sorted form. If we were to push it directly, then the values can be mismatched and the then it will not be a no then it will not be in non-decreasing order. That's why. So first we compare if num1 index value is more than nums2 index value, okay, and nums2 is the j comparing from the last index value of nums2 and last index value of j, okay. If this true, I minus minus and nums1 in the nums1 constant we will store nums1 index value. Okay, nums k is equals to n plus 1 index means in the result we will get the first array nums1 with updated spaces and updated values after being compared and arranged in a ascending order means non-decreasing order. Okay, and in the else case if nums1 k sorry if in the else case if nums1 constant is equals to if nums1 constant value is equals to nums2 j, then j will decrease. We will decrease j and k will also decrease in that case. While okay, so it will only check for the values of thus this while loop will only check for the values of the I and compare it with j first, then it will place the values of I according to the j. If j's values are big, then i's value will be at the last index this, okay, like in where that case is gone, like in this case, see nums2 index values are less than nums1, so i's values got stored in the last indexes, like last index became 6 and second last became 5 and third last became 4. After that, when I have become 0, okay, I have become 0 and it will not run for j further this. So after that, we will write another while loop while j is more than equals to 0. What we will do, we will store nums1 constant is equals to nums2 j values means and j is the What we have only compared j here, not decreased or j here. I think else case is also don't needed here. Let's ask it if else case it's needed or not. Is else case really needed? Else case even needed or not? Okay. Okay, that's why I decrease the nums k here. Nums k after this will become nums j. 1 minute, I think if if else is present, then condition becomes clear. If this nums one element, okay, put nums one elements and decrease the index value of nums one. Else nums okay. If nums two elements are big, then okay, that's why it was used here. So bro, else is absolutely never. If I remove the skills, then merge logic breaks. Yeah. If we will remove this, then in the else case, if j will be bigger, then how j values will be stored in that. That's why we use that. And after that, even after that, if j values are left till the first after we have reached the first index of I, then uh, we will simply replace the uh, values of remain left remained empty values of nums1 constant with nums2 j and j minus minus and k minus minus every time. And here also I minus minus k minus minus j minus minus and k minus minus. So k will always decrease because it is on the last index of m plus n size. Okay, this is how the code is working. We will do it again in the next stream by revisiting it, and also we will revisit that problem that we did in the starting. That was kids verify you are a human. Okay, that was product of array expect itself. Okay, so yeah, let me add this in the favorites problem also list also. Oh, I forgot to ask the time complexity also. The time complexity of it will be equals to big of m plus n, right? Not the big of n. We have two pointers that will run for max m or n steps. At every step, comparison and assignment happens. Total comparison plus assignments is equals to m plus 1 or around m plus 1. That's why time complexity becomes big of n plus n. We aren't using extra arrays. Just in place, we are doing in place merge. That's why time complex space complexity is 0, 1, constant express space. So confidently we can say on seeing that this is the algorithm is big of n plus n time and big of 1 space. It works in big of n plus n time and big of one space. Because we are passing one value to both the arrays. Bro, yeah. So today what we have done in today, let's summarize this today's stream. In today's stream, what I have done in today's stream is that what I have done in today's stream is that should I have opened this also to do a trial and let me see merge sorted array. Okay, I forgot to check that also. That that test case. I will add my own test case also. Case 4 and case 5. Case 4 will be what? 1, 2, 3, 4, 5, 6, 0, 0, 0. 4, 5, 6, 0, 0, 0. And here it will be 1, 2, and 3. And here it will become case 5. MS3, MS3, okay. Yeah. Case 4 will be this 1, 2, 5. And here it will be 2, 4, 6. Or maybe we can use 6 and 1 here. Nums 1 must be non-decreasing. Case 4 non-decreasing. Okay. 2, 5, 6, 2, 4, 1, 1, 2, 4. Should be 1 to 4. And in case 5, I think this is right. Yeah. Case 5, okay, what do you think? 1, 2, 5, 3, okay. Sorry, 2, 3, and 5 because it said it should be in non-decreasing order. Set test cases have been accepted. I will just submit it. I think it will be submitted with the test cases also. Let me check. I haven't checked it before that. Do the test cases also get stored in the history? One, two, two, three, four, five. Okay. 1, 2, 3, 4, 5, 6. The weather is hot. Today it was planned that 1 minute. Let me. Okay. So let me check if the test case is also added or not. Okay, test cases will remove after that. Give me 1 minute time. After that, I will summarize the stream. Uh, Stream is going on. it's saying we can. I think I try another new problem today in today's stream. I think we have time left or what? Okay, 1 minute. Let me think if I should extend the stream or not. The new problem is array partition. If we will see this, if it will be solved in less time, I think we can jump onto this. Array partition, given an integer array noun of 2n here, group these integers into n pair, such that a sum of meaning even for all I maximus and maximus. In the input, if we see that, okay, I is 1, 4, 3, 2, output is 4, all possible pairings, ignoring the ordering of elements. So the maximum possible sum is 4. 1 into 4, comma, 2 into 3, minimum of it, 1 and 4, plus minimum of 2 and 3 is equals to 1 plus 2. The greedy sorting, counting sort. Or I think, should I, what was that? Okay, I think the daily question. If you solve a daily question, we get that batch, I think. Now or never. Zero straight. This is a hard level problem. And include topics like this. We can't do this now because we are. So I think what should I do now is what if I ask it from Copilot and try it a little, give it a little try. If it happens quickly, if it, like in less time, then we will do it. Or if it not, then we'll leave it. Yes, sorry, but sorry. Can you explain what we have to do in array partition problem? Merge sorted arrays, merging sorted arrays. Okay, we will not check it inside that. This we will pin this for tomorrow. If I think if I get stuck at any point and at explaining or revisiting, then we will we will continue from that point. In that chat, it will help. I will ask it in a new chat. There a partition problem lead code is about maximizing. My mic working or not? Okay, maximizing. Yeah, mic is working. Okay, fine. Is about maximizing the sum of the minimums of pairs formed from an array of length. Problem statement. You are given an array nums of length 2 into n. You must divide it into n pairs a1, b1, a1, a2, b2, an, bn. For each pair, you add minimum of ai, bi into your total. Goal maximize the total sum of these minimums. The idea in each pair, only the smaller element contributes to the sum. To maximize the sum, we want the smaller elements to be as large as possible. The trick: sort the array and take every alternate element or even indices. Sorting ensures adjacent numbers of clauses. Example walkthrough. Okay, pairing adjust. This is all just um, English. Okay, sort 1, 2, 3, 4 pairs. 1, 2, 3, 4 sum 1 plus 3. Okay. Example 2. Sort pairs 1, 2, 2, 5, 6, and 6. There will be sum will be 9. Okay, so we have to calculate the sum of pairs with the big starting with big minimum values, like plain the problem. Explain the problem in easy English. What's happening in this problem? You have an array with even number of elements, like 2 and 2 n numbers, even number of elements, but uh, it is not even. You need to make pairs out of them. From each pair, you only take the smaller number, okay, then minimum. Then you add all those minimums together. That's the final score. The goal is to make pairs in such a way that this total score is as big as possible. Simple trick. If you sort the array, numbers become arranged from small to big. Now, if you take every alternate number starting from the index, first one index 0 to 4, those are exactly the minimums of the best pairs. What it's saying, we can create pairs like if you sort that, okay, from small to big. Now, if you take every alternate number, okay, one after another, starting from the first one, 0 index, then second index, then fourth. Okay, it is saying that in minimum we should take like first index, then third in, sorry, zeroth index and second index, excluding this. In this case, zeroth index, then second index, then this index. So 6 into what it will be okay 9. So not 6 2 into but it will be 5 then 6 7 8 9. Optimal pairing 2 1 2 5 2 1 2 5 6 and 6. Minimum is 2 1 plus 2 5 plus 6 is 1 plus 2 plus 6. 1 plus 2 plus 6. Okay, 1 and yes 2 and 6. Sort the array, pick every second number and add them. That's the whole problem in easy words. Okay, sort the array. If we are sort the array in the ascending order, sort nums dot begin comma num dot end. Okay, we will sort it. After that, what we will do? Take every second number, add them up. How I can take every second number is like if what nums, sorry, if index, I think we could create a for loop here and go till the last index, starting from the first index, that is I is less than nums dot size and I plus plus. After that, inside this, I think we can do like what if I which index I divided with 2 not equals to 0, then we have to we can I think we can create an what we can create an variable result is equals to 1, so okay 0, and what we'll do result plus equal to what result plus equals to nums I in this case, and I think after that what it is saying add them up, but how okay the condition closed here sorting and sorting for sorting we should not use any. Okay, now I think this is right. For loop function ended here, for loop ended here, condition ended here. Okay, it's now formatted. Now let's should I run it first? Check for it. Sort num dot begins. Expected what? Okay, okay, okay. Uh, 1 to 3. 1 to 3. Then function let for loop ended here. If condition ended here. Am I going in the right direction? Okay, I'm almost there. But okay, in the loop condition, the logic is a little wrong. What's wrong in your code? I divide by equals to not equals to is not the right way to check alternate indices. For example, when I is equals to 2, comma, I divided by 2 is equals to 1, condition true, okay. But when I is equals to 4, condition true again. Basically, this condition is not selecting the correct elements. What you actually want is take every index 0 to 4 after sorting. Correct direction. I you should use okay instead of this I model 2 is equals to 0. Okay, yeah. Model 2. If remainder if it gives remainder 0, okay. That way you will add num0 plus, okay. Summary sorting is perfect. Part is loops. Part needs small fix, then return result, okay. At the end. At the end we have to return result. If this problem was that easy, why it can be this easy, man? Okay, I think we are near to the result. I model 2 is equals to 0, okay. Yeah, the logic is not when we will do I model 2 is equals to equals 0, it will check if index I is divided when divided by 2 gives the remainder 0 not. If it gives the remainder 0, then we will add nums I index value into that. Okay, this was the okay, this problem was not that big. Nice. Brother, it was a very quick problem. How? But, okay. Absolutely, bro. Yeah, this problems seems quick because logic is greedy. No, because logic is simple greedy. White fields with no complete data structures. Just we need to sort and we have to pick alternate elements, no nested loops. Here. So I think the time complexity of this will be equals to big of n log n. Okay. That formula type solution sort then sum of even and dice them. Why greedy works here? In every pair, small elements count. If we pick adjacent elements after sorting, then small elements is the max possible, are the max possible. That's why alternate pick is best, and we don't need any trick. This is the correct, and that's why the problems looks quick, like straightforward greedy plus sorting. The time complexity of this big O and log n, right? And yeah, it will be big O log n because we're sorting, and then after that we did this. We used only single for loop. So if we submit this, okay, and space complexity of this will be big of 1. So brother, this is the most optimized code for this. Okay, this is already the most optimized solution for the array partition problem. The problem boils down to maximize sum of minimum. Sorting plus picking every alternate element is the greedy strategy that guarantees maximum sum. There is no faster way than sorting because you must know the relative order of numbers to pair them correctly. If I am okay, then time complexity sorting dominates, space complexity big of 1, and place sort plus just one variable. Can it be faster if the input range was very small, like bounded integers? You could use counting sort to use sorting to big of n. But in general case, normal tables is the best we can. So this below code is final optimized solution for this problem. It's one of these quick plus greedy problems when where the trick is simple but powerful. Do you want me to also show you how to explain this optimization point in simple words for a stream audience? Yes, like how and why we have. taken even value only, like okay, taken and even values after sorting the array. After sorting it, it gets in the ascending order. Okay, means smallest to big. So first value, third value, and sorry, first and third and fifth, and yeah, it's it picked the first index value and then right and then third and then fifth, right? If there are six elements, I think I have written something wrong in this. Okay, after sorting it looks like this. If we pair them, A0, A1, A2, A1, A A4, A5, A0, 1, 2, 3, 4, 5. Okay, the maximum of each pair will be the minimum of each pair will always be the first element of that pair. That is the even index. Even index 1, 2. So the minimum becomes A0, A2, and A4. Yeah, A0, A2, and A4 means 0th index, third index, and fifth index. See, I have written it here also. So the sum becomes 0th index plus second index and fourth index means first value, third value, and fifth value if in case there are six elements in the array. So the sum, this is why we pick only even indices. They represent a smaller number in each sorted pair. Example of six elements: 6, 2, 6, 5, 1, 2. Sort when we sorted 1, 2, 2, 5, 6, 6 pairs 1, 2, 2, 5, 6, 6. Minimums 1. Index 0 is 1. Index 2 is 2. And index 4 is 6. Sorry, I was one for a second. I'm back. So yeah, so sum will be equals to minimums of 1 is index 0. Okay, first pair is index 0 and second is index 2. Sorry, minimums in the first pair it is index 0, in the second it is the index third index, and index 4 in the 1 minute. I forgot because of the disturbances getting in the live stream. Yeah, it will be like this that I told you. First, then third and fifth. Okay. So in this pairs, we will pick the first 0th index and third index and fifth index, and this 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 is all in the right. These all are in the all are the minimums. Okay, of these pairs. Like in the first one is the minimum, and the second is 2 is the minimum, and the third 6 is the minimum. So total sum is comes equals to this. So yes, first, third, fifth element, easy way to explain. Sort the array, make pairs of neighbors. Always the first element of each pair contributes. So just add all even index values. Okay. So when we sorted it after that, we initialized the result with 0. We ran the loop, we ran a loop starting from the 0th index, goes till the last index, and I plus plus. Inside this, we check if index, okay, not index value, if index modulo 2 is equals to 0. If we divide index by 2 and it gives modulo 0, then the result we will add the nums I index value, okay, and we will return the result. By this we will get the sum of the maximum sum possible by adding minimum values. So that's how the code is working. So now I will quickly summarize the stream, what we have done in this today's stream. The ranking is not updated yet, but I think it will get updated tomorrow before we before we go live again. Okay. What we done in today's stream? First we revisited the problem. First we revisited this problem, monotonic array, and first we done it with a better approach. I think it was a better approach, and the time complexity of that was big of n equals to big of n. After that we did it with the most optimized approach, that was big of 1. Okay, means horizontal, you can say it is near to the x-axis, and the more it is near to the x-axis, the better the optimized, the better you can see the time complexity is, and the near the time complexity graph is like line is near to the y-axis, the time complexity is worse, you can say. And after that, after the revisiting the first problem, we revisited second problem, that was product of array expect itself. We try to run it again and try to understand it by own again also, and yeah, we will understand it again also in tomorrow's stream. And okay, so in today's stream we revisited 2 problems. After that we did 2 new problems. The first one was merge sorted array. We will revisit this problem also again tomorrow. And first let me tell, in the second revisited problem, the time complexity of this was equals to big of n, because we only used single for loops here. And after that I jumped onto new problem, that was merge sorted array, and did it. And the time complexity of this was equals to, let me see, the time complexity of this was equals to big of m into n, because we used 2 variables and did operations on m plus n, okay, variables together. That's why the time complexity of that was equals to big of m plus n. After that we jumped onto our second new problem, that was array partition, that we did the last, and it was very easy. We first understood the problem with the help of Copilot and used this solution. This solution is equals to big of n log n, because we use sorting in this, and after that we used single for loop here and return the result. And the time complexity of this is I have already told this, time complexity of this is equals to big of n log n. So this was all for it today. We revisited 2 problems in today's streams. And yeah, the first problem that I revisited, I did it with 2 approaches, a better approach and after that optimized approach. After that I revisited the second problem, that was product of array expect self, and the first one was monotonic array. Okay, after that I jumped onto a new problem named merge sorted array. We did it. After that I again jumped onto another new problem, that was array partition, and did it also. So in today's stream we revisited 2 problems, total 2 problems, you can say. We revisited two problems in today's stream, and after that we did 2 new problems in today's stream. So that was all for today's stream. So if you learned something from this stream, please do like the stream and make sure to subscribe to the channel, and please give reviews in the comments, so that and tell me that if something that I can improve, or if something needs to be improved, or and what are the things or changes I can make, or should I make changes in my approach or any other thing. And yeah, it will help me. Your reviews will help me understand that how am I performing on the stream. And by subscribing, by when you subscribe, it boosts my motivation and encourages me to come again live and do these things and in a more better way, and explain the things to all of you in a more better way. So that was all for it today. I think I should end the stream now. Okay. So I think today no one has came on the stream, or maybe okay. So in today's stream, those people haven't come today. I think they are busy. They have been busy today, so I think they will come tomorrow. We will see that. I was thinking to do the problem, the second problem from the very starting, but it was just in my mind. But after I did this problem, I think I got a thought too. Why shouldn't I do that? Try that. So I tried that, and yeah, you see that I also solved it in front of all of you. So it was a good stream. Today's stream was a good stream, I can say. So that's all for today. Now I think I should end the stream. So don't forget to like the stream if you learn something from it, and make sure to subscribe to the channel and give reviews in the comment section. So till then, keep learning and keep exploring.